Hello everyone, welcome back to the Electrical Circuits and Network. Today we are going to discuss mesh analysis, which is based on Kirchhoff's voltage law, which we have already discussed in the last session. Also we have solved some numericals based on that. So let's get started with mesh analysis. The mesh analysis is used to calculate unknown currents in the circuit, and it is done by using KVL. KVL means what? Kirchhoff's voltage law. What are the steps involved in this? First, we will identify various nodes and mark all the possible branch currents and loop currents with some assumed direction. Generally, we assume clockwise direction in all the numericals. Okay. This is our assumption. The direction of current is assumption. If our answer is positive, then assumed direction is correct. If the answer is negative, then assumed direction is wrong and it will be opposite to assumed one. Okay, like this will be our assumed direction. Then, and while marking this unknown currents, we have to mark the currents such that the number of unknown currents will be minimum. Okay, so it will be easy to calculate. Then apply KVL and write equations for each closed path. Number of closed path equals to number of equations. Number of closed path will be equals to number of equations. So if we have two closed paths, then we will get two equations to solve. Okay, then against this solve equation and obtain magnitude and direction of all unknown currents that we want. Okay, let's solve this problem. Write equations only to solve this network using loop analysis method. Write equations only to solve this network using loop analysis method. Here we have to write only loop equations. We are asked to write only equations here by applying KVL. Identify here what are the closed path. This one is closed path, this two also closed path, and this big one also closed path. But we are doing here what? Mesh analysis. Mesh analysis. We are going to solve or write this equation by using this method. So what are the mesh involved here? This is first mesh and this is second mesh. Mesh is what? Closed path in the circuit. It is the smallest closed path in the circuit, and this will be the first and this will be the second mesh. Here two mesh are there, so we will get two equations here to solve. Okay, so first we assume the direction of current in this two mesh. Okay, suppose this is the current I1 flowing in the mesh 1 and I2 is current flowing in the mesh 2. Okay, now we will assign the values. Assign the signs to this. As the current is flowing in this direction clockwise, so this will be plus, this will be minus. Okay, here battery is there, this is negative and this is positive, and this through 8 ohm, current is flowing I1 in downward direction, but I2 in what? Upward direction. So the current flowing through 8 ohm will be either I1 minus I2 or I2 minus I1 according to the magnitudes and directions of these two currents. Okay, so first we'll apply KVL, Kirchhoff voltage law, to loop 1. Okay, what is loop 1? This is loop 1 from here to here, again from here to here and back to this position. Okay, this is total loop 1. So we will write KVL equation to loop 1. Suppose we are starting from this point minus to plus, so plus 10, then plus to minus voltage across this 2 ohm will be 2 into current flowing through that resistance, that is minus 2 I1. Then minus 2 plus, so it will be potential rise, so plus 20. Again, as we are considering loop 1 only, so we will assume that the I1 current is greater than I2. This is our assumption because we are applying the KVL to loop 1 only, so we will consider loop 1 only. So this will be we assume that the I1 is greater than I2. So what will be the voltage drop across it? 8 into current flowing through this 8 ohm. That means I1 minus I2. Okay, equals to 0. Then this 10 and this equals to 30 equals to this minus 2i and this minus 8i will be 10i1 and this minus minus will be plus. So, and on the right side when we take, it will become minus 8i2. That means now our equation 1 will be 10i1 minus 8i2 equals to 30. This is our equation 1 of this loop 1. Okay. Now let's apply KVL to loop number 2. Loop number 2. Let's see the diagram. Here, suppose this is our starting point. Okay, suppose this is our starting point. We are going in this direction and come back to this point only. So from this 5 and the voltage across 5 will be what? 5 into current flowing through that resistance, that is 5i2. Okay, then again 8i2 minus i1, because now we are in loop 2. So the voltage drop across 8 ohm will be 8 into I2 minus I1. Here I1 minus I2, now it is I2 minus I1. So let's write that. So minus 5I2, okay, then minus 8, now it is I2 minus I1, okay, and this is voltage source. And we are moving in this direction, so plus positive to negative, negative 20 volt equals to 0. So negative 20 volt equals to 0. Solve it. 5i2, this is minus 8i2 plus 8i1 is minus 20 equal to 0. This will be what? 8i1 minus 13i2 equals to, if we take this 20 on the right side, it will be like this. This is the second equation we want. Because in this way, we get two equations, because we have here two loops are there, so we will get two equations. This is the required equation. This is the equation number 1 and this is the equation number 2 that we want. Okay. So let's solve another example. See here, the question is calculate current flowing through 6 ohm resistor using KVL. 6 ohm resistor using KVL. First we will identify how many number of mesh we have here. Okay. Number of mesh. This will be the first mesh and this is second mesh. So number of mesh will be 2. So number of equations will be what? 2. So we will assume the clockwise direction for loop 1 and this is also clockwise direction. We will assign the current I1 and I2 flowing through the loop 1 and loop 2 respectively. So we want the current flowing through 6 ohm resistors using KVL. So first we will apply the KVL to loop 1. We will get first equation. Then we will apply the KVL to second loop. We will get second equation, and by solving these two equations we will get the values of I1 and I2. And the current flowing through the 6 ohm will be what? Either I1 minus I2 or I2 minus I1 according to the magnitude we will get. Okay. So first step will be what? Apply KVL to loop number 1. Loop number 1. So start from this point and again come back to this point. Minus to plus, positive, that is potential rise, so plus 20. Then this will be the plus and this will be the minus, as the current always flow from higher potential to lower potential. So minus 5 into this current I1. Okay. Now this is 6 ohm and we are applying KVL to loop 1. So we will assume that IN is greater than I2. So I1 minus I2 equals to 0. So plus 20, this minus 5I1, this minus 6I1 plus 6I2 equals to 0. So this will be what? Minus 11I1 plus 6I2 equals to minus 20, or we can write like this, or change the signs of all. 11I1 minus 6I2 equals to 20. This will be our equation number 1 when we apply KVL to first loop. Then let's apply KVL to this loop. So this is 10, this is 15 and this is 6 ohm. So write that equation. Here apply KVL to loop number 2. Okay, loop number 2. Here this, let's start from this point. 10I2, then minus 10I2, then plus to minus, minus 15 and again 2 through this resistor. So this minus 10I2, then minus 15 and minus 6. Now we are in the loop 2. Okay, so I2 will be greater than I1. So I2 minus I1 equals to 0. This minus 10I2 minus 15 minus 16I2, 6I2 plus 6I1 equals to 0. So 6I1 minus this 10 and this 6 minus 6 and 6 minus 16I2 equals to 15. This is equation number 2. And what is your equation number 1? 11I1 minus 6I2 equals to 20. 11I1 minus 6I2 equals to 20. This is our equation number 1. Solving this equation number 1 and 2, solving this equation number 1 and 2 with the help of either calci or our general matrix method, or putting the values of I1 in equation number 1. Suppose we are putting the values of I1 in equation number 1 and solving for I2, and then put the value of I2 in equation number 2 for solving for I1. We will get the values I1 equals to minus 0.32 here. Okay, and this is I2 and this is I1 equals to 1.64 ampere. Okay, these are the values got from by solving these two equations. But we have asked here to calculate current flowing through 6 ohm resistor. Okay, so current flowing through 6 ohm resistor will be I6 ohm equals to I1 minus I2, because this is greater than this. So 1.64 minus 0.32 equals to, this will be 6 and 9, 1.96 ampere. This is the required current value that is flowing through 6 ohm resistor. In this way we can calculate the required values of unknown currents with the help of mesh analysis by applying the Kirchhoff's voltage law to a particular loop. Okay. Now let's solve another example. Now the next question is, find the current in 15 ohm resistor using mesh analysis. Okay, this is the question. This is the circuit given, where this is the first loop and this is the second loop. Here number of mesh are 2, so number of equation we will get will be also 2. Okay, so this will be the I1 and this will be the I2 current flowing through these two loops. So first we will apply, this is also similar to that we have solved earlier. So apply KVL to loop 1. This is loop 1 and this is loop 2. Okay, this is loop 1 and this is loop 2. So here this is negative, this is positive. So negative to positive, 30, positive 30, then minus 30 I1, 30 I1. Then through this 10 ohm, observe here I1 is also flowing and I2 is also flowing. I1 in downward direction and I2 is upward direction. So, and we are in the loop 1. So for us I1 is more than I2. So 10 I1 minus I2 equals to 10 I1 minus I2, and this is also plus 2 minus 60 equals to 0. Okay. Now this 30 and this 60 minus 30, this 30 I1 and minus 10 I1 minus 40 I1 and plus 10 I2 equals to 0, or 40 minus 40 I1 plus 10 I2 equals to 30. This is equation number 1. Okay. Similarly, when we apply the KCL to loop number 2, apply KCL to loop number 2, we will get the equation as this is 10 and this is 10 I2 minus I1, 15 I2, and this is, we are going from this to this, negative to positive, so positive 60. So we will get positive 60 minus 25 I2 plus 10 I1 equals to 0. So 60 equals to 25 I2 minus 10 I1. This will be our equation number 2. So by solving equation number 1 and equation number 2, how to solve? Let's see here. This is our first equation, 40 I1 minus 10 I2 equals to minus 30, and we have the second equation, minus 10 I1 plus 25 I2 equals to 60. This is our second equation. If we eliminate one of these two, I1 or I2, we will get easily the value of second one. So multiply this equation number 2 with 4. So we will get minus 40 I1 plus 25 into 4, 100 I2, 25 into 4 into 60, 240. This is our new equation number 2, and this is our 1. So add this equation 1 and this 2. Okay, when we add equation 1 and equation number 2 star, we will get this 40 and this 40 will cancel. This minus 10 and plus 100 will be what? 90 I2 equals to this 240 minus 30, 210. So I2 will be 210 divided by 90, and we will get this 2.33 ampere. Okay, 2.33 ampere. So see here, In this way we can calculate this I2, and then by putting the value of this I2 either in equation 1 or 2, we will get the value of I1. But our question is what? We have to find the current in the 15 ohm resistor using mesh analysis. Here 15 ohm is here. So current through 15 ohm is I2. So we have calculated that I2 is what? 2.33 ampere. This is the required value of current. Okay, in this way we can solve. Now, this is a similar question. Here also there are two mesh. This is loop 1 and this is loop 2. So we will get two equations. Okay, we will get two equations, and we want the current through 2 ohm resistance. So this will be 2 ohm resistance. So current flowing through 2 ohm is, if it is I1 I2, then I1 minus I2 or I2 minus I1 according to their magnitude. So try this and let me know the answer in the comment section below. Okay, we will solve this equation in the starting of next session, and this is our end of our third unit. From next session we will continue with our fourth unit, that is network theorem. Okay, till then stay tuned and keep learning. Thank you.